Hi, welcome back to my channel pibyme Maths. This is by WST01. Here we are solving October 2024 Statistics 1 paper. In part 1 of the video, we have covered question number 1 to 3. Let's look at question number 4. This is from normal distribution. The distances m miles a motorbike travels on a full tank of petrol can be modeled by a normal distribution with mean 170 and standard deviation 16. So you can write x follows normal distribution of 170 comma sigma square mu comma sigma square part A. Find the probability that on a randomly selected journey the motorbike could travel at least 190. At least 190 is greater than or equal to 190. So if you rewrite it, you don't need to rewrite it, you just standardize it. Using this coding, z is x minus mu over sigma. That's how we standardize the normal distribution. So z is greater than or equal to x minus mu over sigma. So z is greater than or equal to 20 over 16. 1.25. To find the area on the right hand side of a positive number, you can do 1 minus p of z less than 1.25. The less than or equal to or greater than or equal to, the equal sign doesn't really matter here because we are talking about continuous random variable here. So whether you put the equal sign or you don't put the equal sign, you won't lose mark, don't worry. So we need to use the table to get this value. So the value corresponding to 1.25 is here, 8944. So it's 1 minus 0.8944. You will get 0.1056. You can just leave it as it is actually. Or you can round, in the next step you can round it to 3 significant figure. That's all, just a 2-mark question. Let's move on to part B. The probability that on a randomly selected journey the motorbike could travel at least d miles, that means p of x is greater than d, on a full tank of petrol is 0.9. Find the value of d. Again, standardize this. Z is greater than d minus mu over sigma is 0.9. Okay, you need to remember this before you use the table. You should know whether this value is positive or negative. It has to be positive if you want to use the table. So if you look at the bell curve, we know the total area below the curve is 1, right? The mu is 0. For standard normal distribution, mean is 0. So we know this area is 0.5, this area is 0.5. So here in this question, they are talking about, when they say z is greater than, they are talking about the area on the right hand side of the point, and the area is bigger than 0.5. So definitely the point cannot be here, because if it's here, this right hand side area is not bigger than 0.5, right? So it has to be here, this value d minus 170 over 16 should be here, so that the area on the right hand side is bigger than 0.5, right? So what I'm trying to say, it's a negative number, so you can't just blindly use the table. Okay, so now we know this value is a negative value, d minus 170 over 16. It cannot be negative if you want to use the table. It has to be a positive number. So how do you change the negative to positive? You see, the area on the right hand side of a negative number is same as the area on the left hand side of a positive number. You see how I am changing it to positive? I multiplied by negative 1, or just swap these two numbers so it becomes positive, right? Now forget about this one. We have taken a positive number here and the area on the left hand side is 0.9. So definitely the area on the right hand side is 1 minus 0.9, 0.1. Why we are doing this? Because there is no 0.9 in the smaller table. We have 0.1. So let's look at 0.1. 0.1 is here. The corresponding value is 281.2816. 1.2816, that's actually 170 minus d over 16. So make d as a such. So it's going to be 1.2816 times 16. And 170 minus this ends 149.4944, 149.49 dot dot. So you can round it to 3 significant figure and write it as 149. That's all. 3 more questions. Let's look at question number 5. We have a histogram given, time in hours and frequency density. The histogram shows the number of hours worked in a given week by a group of 64 freelance photographers. Part A is a 1-mark question. Give a reason to justify the use of a histogram. Definitely, we are talking about time here, right? If they are talking about time, length, mass, these are all continuous random variables. So you can just write time is not discrete, it's continuous. That's all. Just a 1-mark question. Part B. Given that 16 of these freelance photographers spend between 10 to 20 hours working this week. Between 10 to 20 hours, there are 16 of them. Estimate the number of photographers that spend between 12 to 24. It's one of the common question in histogram actually. So there are several ways you can answer this. So one of the ways is by looking at compare the known quantities first. Look at the known quantities in the histogram. 10 to 20, where is the bar 10 to 20? This bar represents 16 workers. And they are asking 12 to 24, how many? 12 to 24, okay? 24 is here, let's say. I'm gonna draw a line here. This is 24 and 12 is here. 12 is here. So we need to find out how many numbers of freelance photographers working between 12 to 24 hours. That's the question, right? Okay. Now, let's look at 10 to 20. It says 16, right? So this bar represents 60. Which bar? This bar. 10 to 20 represents 16 photographers. So find the area of the bar. Here it's 20 minus 10 is 10. The length is, take it as 1, 2, 3. Or you can take it as, if you want, you can take it as 0.5, 1, 1.5. This is 1.6. So 1.6 times 10, that's the area. You will get 16, right? So the area of this bar is 16. That represents 16 photographers, right? Now we need to find the area of this bar, and then we need to find out that area represents how many photographers, right? So 12 to 24, we need to find the area between 12 to 24 now. So I'm going to find the area between 12 to 20 first. The area between 12 to 20. So here the length is 20 minus 12, 8. This is 1.6. So 8 times 1.6 plus. Now the area between 20 to 24. The area of this bar. 20 to 24. 24 minus 20 is 4 here. Times. The height is 2.5, 2.678. 2.8, that's the area. So I'm going to calculate this. 8 times 1.6 plus 4 times 2.8. I got 24 as the area. 24 is the area, right? So 16 represents 16 people, 24 represents 24 people, right? That's all. You can't just show this diagram as the working because it's a 3-mark question, right? So what we can do, you can write the first one, the area we got, right? 16 times 10. So you can write 16 times 10, sorry, it's not 16 times 10, it's 1.6 times 10 is equal to 16. You can write area is equal to 16 photographs. And then write area is equal to 0.8 times 1.6, 8 times 1.6 plus 4 times 2.8 is equal to 24 is equal to 24 photographs. This diagram is just for your reference. That's all. Part C now. Find an estimate for the median time spent working in this week by these 64 freelance photographers. So we need to use a linear interpolation method here. To use linear interpolation, you need the frequency and the cumulative frequency, right? There are 64 of them. To find median Q2, you need to divide 64 by 2. You will get 32, right? We need to find out where this 32 lies in the cumulative frequency. Okay, to find the cumulative frequency, you need the frequency first. So look at the histogram. The interval is 0 to 10. I'm going to rub off all these things now. Okay, on 10 to 20, 20 to 30, etc. Right? Okay. Here, 0 to 10, the area is 10 here, 0.5 here. So 10 times 0.5. 10 times 0.5, it's 5, right? Okay, here it's 10 here, 1.6 here, 10 times 1.6 is 16. But in the first part it says, this bar represents 16 workers, 16 photographers. So you can take this represent 5 photographers, right? So here, for the first one, the first bar, the class interval is 0 to 10, 0 to 10. The frequency is just 5. From 10 to 20, it's 16. Then cumulative frequency is 5 here, 21 here, but we are looking at 32. Let's find the next interval, 20 to 25 now, 20 to 25. The area of this is 1, 2, 2.5, 2.678. 5 times 2.8. 5 times 2.8 is 14 actually. So for the next interval 20 to 25, it's 14. When you add, you will get 35. Definitely the 32 lies in here, right? So we're going to apply linear interpolation method. You write the class interval 20, 25 and your Q2 should be somewhere in between. And then write the corresponding cumulative and the previous cumulative, put 32 in between and apply the linear interpolation. Q2 minus 20 divided by 25 minus 20. This ratio will be same as this ratio, 32 minus this, 35 minus this. 32 minus 21 over 35 minus 21. Make Q1 as a subject, so you will get 32 minus 21 is 11 over 35 minus 21, which is 14, right? Times, you bring the denominator here, it becomes multiplication, and then bring the 20 here. Make Q1 as a subject, sorry, Q2 as a subject. So plus 20. So you're gonna get 11 over 14 times 5 plus 20. 23.9 etc. So round it to 3 significant figure. 23.9 is the median. That's all. That's linear interpolation method. Let's move on to the next part. Charlie decides to model this data using a normal distribution. Charlie calculates an estimate of the mean to be 23.9 hours to one decimal place. So the mean is 23.9. We got median is also 23.9 something. Comment on Charlie's decision to use a normal distribution. If you are comparing these two, mean is approximately equal to median, right? Because if you want to use a normal distribution, the data has to be symmetrical, right? We always use the bell curve, right? It should be symmetrical about the middle line. But if you look at this histogram, right, it's not symmetrical actually. You have a long bar here, right? It doesn't look symmetrical. But you can use these two data. Since you are given mean, you can say mean is approximately equal to median, therefore the decision is appropriate. The decision is appropriate. That's all. 2 mark question. Question number 6. A biased die with 6 faces is rolled. The discrete random variable x represents the score which is uppermost. Okay. The cumulative distribution, as you can see, it's capital F of x, is given. Find the value of k. Always remember in f of x cumulative distribution that the last value should always be 1. The last value, because sigma p of x is 1, right? Probability. Sum of all the probabilities should be equal to 1, and we are finding cumulative by adding all the probabilities, right? So total should be 1. So 10k is 1, k is 1 over 10. Now find the probability distribution of x. So the probability distribution, I put the table here again. It's a 3 mark question. We need to find p of x. The first value, write it as it is. To find probability from cumulative, you take the corresponding cumulative minus the previous one. This is 3 over 10 is 0.3 minus 0.2, 0.5 minus 0.3, because the value of k is 1 over 10, right? 0.7 over 10, 0.7 minus 0.5, 0.10 minus 0.7. That's a probability distribution. You can write the probability separately or just draw a table with the values of x and p of x. That would be the probability distribution. A biased die with 8 faces is rolled. The discrete random variable y represents the score which is uppermost. The probability distribution is given. Given that e of y is this, solve 2 equations a and b to show that a is this. You need to frame 2 equations. We know sum of all the probabilities is equal to 1, right? Sigma p of x is equal to 1. So when you add 1, 2, 3, 3a plus 3b plus 0.11 plus 0.05 is 1. So 3a plus 3b is equal to 1 minus 0.11 minus 0.05. You get 0.84. You can divide this by 3 also. You will get 0.28 when you divide throughout by 3. Take it as equation 1. Okay, I have put the table here. We are going to frame another equation using this. How do we find E of y? Y times P of y, right? And sum up. So a plus 2a plus 3a plus 4b plus 5b plus 6b plus 7 times 0.11 plus 8 times 0.05. This is E of y, but it's given as 4.02. Frame another equation. You'll get 6a plus 15b is equal to, get 4.02 minus 7 times 0.11 minus 8 times 0.05. We'll get 2.85. So you have two equations. Solve the simultaneous equations and get the answer. So you need to show one or two steps how you are solving it. Since it's the easy part, I'm gonna skip that. So the values are 1, 1, 0.28, 6, 15, 2.85. A is 0.15 and then B is 0.13. That's all. Part D now. Show that E of y square is this. Okay, I have put the table here, so you can write E of y square as you square y multiplied by this. 1 square is 1 times A, 2 square is 4 times A, 3 square is 9 times A, 4 square is 16 times B, 25 times B, 36 times B, 7 square times 0.11, 8 square times 0.05. It's gonna be 10, 14A plus this is 50, 61, 67, 77B plus these values and then get the answer. You should get this. We know the value of A and B, 0.15 and 0.13. So you can write it as 14 times 0.15 plus this is 50, 61. When you add the B, you'll get 50, 61, 67, 77 times 0.13 plus 49 times 0.11, 8 square, 64 times 0.05. Let's calculate this. 14 times 0.15, 77 times 0.13, 49 times 0.11, 64 times 0.05. You should get the answer. 20.7. The good thing about this question, the answer is given here. Now part E is a 3-mark question. First find variance of y. The formula is E of y square minus E of y whole square. We just got E of y square 20.7 minus E of y is given as 4.02. 4.02 square. Calculate this. Now you can find variance of 5 minus 2y, which is using the formula minus 2 square variance of y. We are using this rule. Variance of ax plus b is a square variance of x. So it's going to be 4 times whatever answer we are getting. So 20.7 minus 4.02 square. 4.02 square. 4.5396. 4.5396 times 4. 18.1584. 18.1584. If you want, you can round it to 3 significant figure. That's all. Let's move on to the last part. These dice are each rolled once. The scores on the 2 dice are independent. Okay. Here, this is the starting of the question. This is a die with 6 faces. We have the probability distribution here. And then there is another die here with 8 faces, right? Now we are throwing these two dice at a time together, and the total score is, find the probability, the sum of these two scores are 3. So what are the combinations that will give you 3? For the first die, the die is a 6 face die, So the numbers are 1 to 6. For the second one, it's numbered from 1 to 8. So to get the total, you need to take 1 to total 3. Total score should be 3. Or 2, 1. That's all right. So probability of 1, 2 plus probability of 2, 1 is. Take the probability of 1 here, 2 here for the first one. So probability of 1 is 0.1. Probability of 2 is A, which is 0.15. So 0.1 times 0.15 plus. Now take the probability of 2 here, probability of 1 here. Probability of 2 from the first one, which is 0.1. Probability of 1 here, which is A, which is 0.15. So 0.1 times 0.15. So it's basically the same thing. So you can just write 2 times 0.1 times 0.15. 0.03 is the answer. That's all.